Okay, good morning and good evening, everyone. Welcome back, and all of you to the 2022 Digital Futures Doctoral Consortium. Tonight, we invite Professor Mette Thomsen. She actually examined the intersections between architecture and the new computational design process. And during the past 15 years, her focus has been on the profound changes that digital technology instigate in the way architecture is thought, designed, and built. I think he make a great contribution for the community. So all of us admire her achievements a lot. So that's why last year, actually, we set up the fellowship of digital futures who can play the leading roles in the community, and also the iconic figure in the discipline to leading us to the future. So Mette Thomsen is one of them. Last year, we invited, and actually Mette also contribute a lot to all of us. Actually, she organized the UIA 2023 Copenhagen, and also invite us to join and participate. So last week also Digital Futures platform live stream another event, pre-event organized by Mette's team. I think in the future also we would like to find more opportunity with her. And this is a fellowship. Actually, every year we would like to invite one or two important academia to participate, who can really help us to address this the futures community to the world. And every year we have this PhD consortium, that is the sharing PhD program. Actually, we want to set up and invited all these important professors, gave us significant gave us lectures from different perspective, and also gave us different knowledge, new knowledge in the discipline. So this year, the Digital Future events, including workshops, we have right now more than 130 workshops. Right now, students are so we have another conference named CDRF, around 50 people. Nice.
Yeah, Philippe, we're losing your voice in the middle.
Hello?
You're still a little bit muffled.
We have PhD. This is the agenda for PhD. So right now in the first poster, including this morning, Daniel this lecture sequence. So all three posters present three different around 15 student PhD candidates take this course. So welcome to join us. And also we open to invite different students who are interested in this topic and to join and register and join with us. So that is the brief introduction of the background. And last but not least, before the Mette's lecture, we also want to introduce the Architecture Intelligence, which is a new journal we launched in June this month. And the Mette also contribute one important papers. In the first inaugural issue, we have 15 essays, which is under editing right now. And we're looking forward to launch this inaugural issue June the 26th. Read this new journal. So today, tonight, and this morning for maybe for the States, and it's welcome to join us for Mette Thomsen's lecture. So also I would like to give a more detailed introduction to Mette, who is the director of the Architecture Research Group, CETA, at the Royal Academy of Fine Arts, School of Architecture, Design and Conservation, where she was pilot a special research focused on the new digital material relations that digital technologies bring forth. Investigating advanced computer modeling, digital fabrication, and material specification, CETA has been central in the forming of an international research field examining the changes to material practice in architecture. So this has been led by a series of research investigations, developing concepts and technologies, as well as strategic projects such as International Marie Curie ITN Network, InnoChain, and the ERC project, Eco-Metabolistic modeling for the architecture design that fosters interdisciplinary sharing and dissemination of expertise and supports new collaborations in the fields of architecture, engineering, and fabrication. I was lucky to be invited to participate in InnoChain. I also have a very deep impression for the culture, sharing culture in Europe. I think it's really important to the PhD students in Europe to share their knowledge on the InnoChain platform. And so Mette also currently the general reporter and head of science track for the UIA 2023 Copenhagen World Congress, the topic Sustainable Futures, Leave No One Behind. So we have already made several promotions on the official platform for that special event, and looking forward next year, UIA could be also organized successfully. And also this event asking how architecture can contribute to the United Nations SDGs. And also I'm also one of the PPC member, professional practice committee member for UIA. I think all of us are looking forward next year in Copenhagen. There's very interesting topics, sustainable futures can contribute to the work. So in today's talk, Mette and Thomsen will discuss how the central contribution of the computational design field can be understood as central stepping stones into the age of sustainability to engage with new renewal, renovative, and restorative material systems. By taking departure in the conceptualization of an extended digital chain by which architecture can address fabrication at a low scale of the material. She asked how these methodological innovation can be transferred to new questions arising from the bio-based material paradigm. And the talk outlines the three central contributions of the computational design field: advanced information modeling, functional grading, and integrated sensoring, and also including the success, how these can be extended to allow new means of instrumental for bio-based materials characterized by the heterogeneous, the behaving, and the living. So now I think I would like to give the floor to Mette. So welcome, we are looking forward to your lecture. Thank you.
Thank you so much, Philip. It's a very nice introduction. Let me just set this up. Just before I start, I thought I would just show you that this Congress, we're having the call for papers right now. There's a call for the 20th of June, the abstract, which is for next year. The abstract is very, very short, and we would really like a very broad contribution. So we very much like that people with different kinds of background, different kind of knowledge fields come and join us. So if you have any chance to write a small abstract, we would be very pleased. And then the full paper is not due till October, and you don't need to do the abstract before doing the paper. So yeah, I'm sorry for plugging here, but I think it is really our chance right now to get these
And also,
things,
I want to add in, Mette,
Yeah.
we're actually also promoting it in our university's website and also in the Society of China's website. Actually, we're also promoting it a lot. I think we should help you to do that. It should be a really important event and also contribute, invited all the PhD students especially to contribute their papers, participate.
Please, please
Thank
do.
you.
I'm so pleased, and thank you very much for helping us with that. So, and thank you for inviting me. For me, it's very, very important to continue this very long relationship with Tongji and with you, Philip. I feel that we are close colleagues and that we have the same agenda, an agenda which is really about trying to figure out what is the real difference that computation makes. How is it that it can create the basis for new ways of building, new ways of thinking about what buildings can be, and at the same time a sort of strong focus on communication. So really trying to get to change gear, to be able to get these knowledges out there so that we can start operating with them. And I was very pleased to be invited today. I'm very pleased to speak to you. I think PhD teaching is really at the core of research, and it's really nice to participate in that broadly across multiple institutions, and especially with you, of course. Today, I wanted to spend our time here together to talk about the way that I've been reconsidering the main impacts of our research over the last years and redirecting it to allow me to start thinking about new ways that we can consider how sorry, I'm just trying to get my, I have some little mouse problem here. Let me just fix it because then I'll feel more comfortable. Yeah. So yeah, to really consider how our research agendas within the digital design field can allow us to ask new questions of sustainability, of who it is that needs to build and what it means to build in time. And these are the sort of core ideas that I want to bring forward. And as Philip said, I wanted to take a sort of point of departure in the existing practice, both our own existing practice, but also the existing practice of our field, and then try to see, well, what are other strategies that the field might be sort of scratching at right now. Maybe it would be nice to, wait a minute, somehow it's not updating sorry, just a moment. I can see my screen. Is my screen frozen? You don't see me change screen, no?
No, it's
No, we're still on the same slide.
Yeah, I don't know what happened here.
Maybe stop share and reshare again.
Yeah, just, I think it's actually my end here. Let me just do it. So I just try again. Sorry, guys. There we go. Yes, and now it should work soon here. I hope it's better. Yeah.
Yes, now we can see the next slides.
Good. Very good. So maybe before I go too far into this, then just to also introduce what CETA is. CETA is the Center for IT and Architecture. It's a research group. We've existed actually for 15 years now. I was in the UK before. I came back to Denmark, here to Copenhagen, and I started the group in 2005. And what we have been looking at, I mean, CETA has been many things over many years, and we've been moving from things that have been mainly revolving around interaction, ideas of virtual reality, to ideas of robotics, to ideas of digital crafting, and now increasingly to biodesign and ideas of sustainability. So I think when you have a group this long, then the group will change and the work will change as it changes with the sort of conditions of the field. At present, our sort of key foci are robotic fabrication, new material processes, big data and machine learning, and here we're talking really about machine learning for fabrication, extended reality and sensing, and then really all the emergent feedback loops that are happening between these different practices, and wondering what kind of new way of representing, of understanding architecture emerges from these technological shifts in the way that we can annotate, specify, and fabricate architectural design. So when we look at it, then we look at computation as a ground research question, meaning that it's not so much about just the surface of what IT provides for us. I think we're often presented IT as an optimization tool. We can do things better, faster, more communicated, maybe cheaper, but really trying to ask, well, what are the fundamental changes that a computation affords us, and especially how does it challenge the way that we think about our material practices and the way that we work as architects. We also run a master's group. It's part of our practice. It's a very, very wonderful platform to be able to test ideas, and we teach in the way that we also research, which is really learning by doing. And here our ethos is maybe the sort of underlying ethos of the research center really comes to the fore, which is that we don't know yet. I think the one thing we know about architecture is that we do not know what future we're educating for. The future that I was taught to participate in is not the reality that I live in, and I think this is radically true of the generations that we're teaching now. We do not know what skills that you actually need. We do not know how you will be working with materials. And the only thing we could know is that the role of the architect is evolving continuously, including new roles such as the machinist or the simulationist or the designer steerer, and asking new questions of how biology and technology can intersect, creating new material platforms that allow us to work between different material paradigms of the geosphere and the biosphere. So really what we want to do in CETA is ask, what can architecture be? What can space afford? And how are the material practice and the representational practices that we work with, how do they actually condition the way that we're working? So I wanted to return to sort of the first question that I was asking, which is really saying, well, how is it that our field can contribute to sustainability? And these thoughts have really been evolving with my role as head of the science track in the UIA group, where I have been working as not only the organizer of the scientific proceedings and the sort of conference part of the Congress, but also as the key voice in articulating the agenda of the Congress. So really trying to say, well, what are the central themes, and how is it that architecture challenges what it is that the SDGs how the SDGs can be achieved. And here I think we can be, we're asking what the role of architecture can play in achieving the SDGs. And we are often presented the SDGs as this quite flat mosaic of equal concerns. And it can be very, very hard to penetrate. It's very easy to tag this on to any kind of solution. My green roof will help life on land, but it is difficult to sort of penetrate deeper into the SDGs. And in a way, we could also say that it's very immediate. It could feel like of course, architecture contributes to the SDGs. It contributes to any societal problem. So it could seem like a very flat question to ask. What I feel that we have been uncovering over the last 2 years of preparation is really to understand that actually this is not as immediate as we think. At present, none of the UN SDGs declare targets that directly articulate architecture as a driver for change. And there are no indicators that evaluate the role of architecture in change making. And I think this is a huge oversight. It's clear that governance does not truly understand the agency and potential of what architecture can really do for the SDGs, how we drive. So a problem statement for the SDG or for the UIA could be that as architects, we are aware of our role in shaping our societies. We understand that we're a fundamental part of the way that we form, the way we live, the way we interact, and the way that we build. But we can also see that when we look to the SDGs, that architecture is hardly mentioned. So what we want to do with the UIA project is to build awareness, both within architecture, but also without architecture, of the impact and ability to afford change in the way we understand and construct the world around us, and communicate this both to ourselves, but certainly also to the UN and to the global society. So I think architecture is architects are incredibly aware of the role that we play in society, but we are perhaps not very good at articulating it. I think in our field, the tagline of sustainable design has been part of our narrative, overarching narrative for at least a decade. So here it's been linked to an idea of optimization, that if we could build smarter with less, de facto build lighter, then we could reduce our impact on the environment, on resource, and on transport and pollution. So this overarching axiom has informed a breadth of projects in CETA and generally in the field as well, examining how computation and automation in its different forms enable us to work in new ways with the traditional materials and in traditional ways with new materials. I think this double has been really helpful, very educative or pedagogic for the field, and this idea of smarter with less has been very practical way of thinking about all the optimization algorithms, all the ways that we've been thinking about digital fabrication over the last 15 years. So here we can say that within this there is embedded thought about how advanced computational modeling driven by big data, either through sensing, simulation, or generative logics, can help us to engage with a whole new degree of material address, in which we are touching the material at the hyper-localized level, being able to design material performance at the nano or micro level of the material. This has allowed us to think about functionally graded materials that are optimized at microscale to high-scale structural performance, all underpinned by the theoretical position that by formalizing material properties and behaviors and devising means of representing their inherent complexity, we can access their underlying computational logics and thereby gain agency to their steering. And I think this is in all the different theoretical frameworks that we see across digital design, and although we are maybe not so good at articulating the differences or having big dialogues between theoretical frameworks, and I think this underpinning, we can see it appearing in the work at the ICD, at MIT, at Michigan, and certainly also at CETA, this idea that digital fabrication allows us to steer materials at the very low scale, and if we can just represent materials, then we can steer them for their optimization. So I think this is a sort of theory. It's not necessarily the truth, but it's a theory that we are all establishing our practices on. But embedded into this theory, there's a series of fallacies that I think mean that we need to rethink how this theoretical framework is forming our practice, and maybe it's time for new theory. Maybe we need to rethink the theoretical platform of our field. And one of them is waste. So digital fabrication is part of industrialization. What happened with industrialization was that fabrication was automated, first just mass produced, and later with the interfacing with computational design through mass customization, we get this digital fabrication framework that we're all working within right now. And as such, as part of the industrialized framework, we are predicated on an idea of waste. We produce a lot of material, we cut out of the material that we might want, or we over-construct, over-engineer our buildings, and we have dead matter lying inside, or dead materials lying there inside of our structures, waiting for the 100-year storm. Or we accept mainly non-additive fabrication principles that allow us to, just in producing our built environment, we need to understand that we're throwing a lot of materials away. So this idea that we are actually predicated on waste challenges us in architecture to really reconsider our material practices, which returns us to the SDGs, and specifically to the panel that Carlo Ratti and myself are chairing, which is called Rethinking Resource, in which we're concerning ourselves with how to consider what the how we can rethink the ways that we are using computation and other technological frameworks to construct our buildings. So it allows us to say that if digital architecture is rooted in an idea of sustainability, if all our projects have some level have said that building smarter with less was a way of achieving a sustainable building practice, it does not truly engage with the idea of resource. It has mainly thought about material practice, but shifting from an idea of material thinking to an idea of resource thinking challenges us to think about how resources are procured and the links that they have in socio-ecological networks, in the socio-ecological networks in which we partake. So going from the idea of being concerned about materials as a sort of blind matter, and now really wondering, how is that material procured? Who lives around it? What is it that when we globalize the use of that material, what happens to the local environment and the local sociological but also ecological networks that perform around these? This is very inspired by the ideas of planetary boundaries, first evoked by Johan Redström, and the very large authorship of their paper of the same name, or it was called the Safe Operating Space for Humanity from 2009, in which they start delineating a series of edges to our planetary system and how we are overperforming, overusing our resource in these 9 different it's more than 9 in these different dimensions of resource thinking. We think we've been presented through this idea, I think, over the last 5-6 years. We've been talking about this idea that we are running out of materials. This is a very quantitative way of thinking about it. We lament the endangered materials, the idea that we are depleting materials, whether it's the sand commons, or we talk a lot about concrete and the problem of sand and gravel, but also certain metals like copper, that we're simply running out of them. But we need to challenge this and think not only that we are running out of materials, but also that as we excavate exponentially more and more, and as illegal mining and other processes of over-extraction are having profound impact on the ecological and social context in which they're part, then it challenges us to rethink what materials we use for what, and whether really just using less is the right way of thinking about it. In CETA, these ideas have driven us towards a bio-based material paradigm in which we think about our material world as one we're participating in, co-producing through practices of growing and harvesting, challenging the perception of our surroundings as inert to something essentially living. And I think this embeds a fundamental repositioning of our correlation to environment or nature, the environment in which we are part. So if sustainability teaches us anything, it is that we are an embedded part of the environment that surrounds us, and that the modernists divide that comfortably placed self and nature at different ends of the curtain wall. We can no longer maintain this illusory idea of a passive world beyond us, which is away from us. Instead, we need to entangle ourselves and partake in inhabiting a world and moving beyond the arrogance of thinking that the world is at our disposal and that we can just use it. So this is also part of a series of new discourses arriving to us from different positions. Here, Critical Zones, that challenges by Bruno Latour and the group around him, which challenges this idea of a global exteriority, that we have somehow other than nature, other than environment. It forces us to readdress our gaze, to see the fullness of space and the densities of particles in our air and the occupation of our soil, in order to visualize the consequence of our actions and potentially to correct them. Personally, I find this image of the microbiome a particularly interesting model for thinking about entanglement. So I like this image because it makes me think about the many models of understanding our body that we've been through in the 20th and now also 21st century. If the system thinkers in the 20th century understood the body as a mechanism, so cybernetics, early cybernetics, thinking of the body as a series of mechanisms that could be steered, then maybe in the sort of mid-20th century, this was replaced by information scientists started telling us about the body as informed by a code, so DNA and RNA. Then I think today we are starting to understand ourselves as entangled, as being co-created by an aggregate of microbiota that exists on or within our tissues and biofluids. It's said that we are made out of 10 to 100 billion microbial cells, and that maybe up to 10 times or 90% of the body, of the cells that we are made of are non-human. So this idea of an interior nature challenges the boundaries of self and environment. Maybe we are also co-constructed, and the nature that we are part of is also right inside of us. Sustainability as a history was born out of the conservation movement, but here the dialogue is very different to what I've just been quoting. Instead, we see nature as something to protect, again, something beyond us, something grand and wonderful, to be protected against man's technologization of energy and resource. And although this is all very heroic and all very positive, then it still confirms the separation between self and environment. It creates an idea of a world that is boundaried and in which environment can be understood as somehow, or nature and wildness can somehow be understood as outside the idea of where we produce and where we resource allocate. And this is of course not true. Nature is the whole thing. Environment is the whole thing. We need to think about that when we are taking resources out of nature, when we are felling our forests, then we are engaging and changing the biological environments that already reside within these social ecological networks. So I think it asks us really fundamental new questions when we start considering sustainability, not just as a sort of add-on onto architecture, but as a theory and a philosophy in itself. It asks us how we can conceptualize in an era of the Anthropocene and an increasingly acute understanding of planetary boundaries. How can we challenge our traditional understanding of design agency? How do we conceive a world view which can no longer be presented as contained and beyond us, but instead in one where we are continually part? And what does it mean in truth to be entangled? And how do we act if we are part of and produced by interacting multi-species socio-ecological networks? And finally, how does sustainability impact our design foundations, such as the humanistic universalism and the ideas of optimization, which I think lie in architectural thinking so deeply. So how do we do this? I think there are different models emerging, and I want to use this talk to talk about two projects that we're doing, operating in two of these different spaces. We could say, well, I've talked a lot about optimization, is the emerging paradigms of Industry 4.0, data-supported physical systems. Is it a route by which we can start about thinking about materials? But what happens when we optimize? We know that when we optimize, it also leads to over consumption of the same materials that we are optimizing. It's called Jevons paradox. And as proved during the Industrial Revolution, we can see that where better coal burning led to the expansion of production, not less. Do we grow it? Biodesign and biotech promises a new technological platform from which we can build our world, not only out of timber or biopolymers, but also synthetic systems where we can design our own organisms to produce the materials around us. Are we entering the plant algacine world, as Birger Lindgren Møller, our colleague here from Denmark, would say? But what happens to the balances of our ecological systems? Can they readily bear this new production realm, or will it just lead to new depletions? We know that planetary photosynthesis is constant. We know that it's called the photosynthetic ceiling, meaning that the amount of photosynthesis cannot extend on our planet. We can maybe not just grow us to new solutions. And finally, can we just recycle it all? Here, this is a project where we recycled silicate glass and 3D printed with used glass. Can we just truly untangle the way that we produce to create the infrastructures for real recycling of the mass of materials needed? I think it's probably a bit of all. It's all four models brought together in different ways, but we need to really be critical about how we are going into these trajectories and how they intersect. So I wanted here to show two of the projects that we're working with. And here, one of them is really about material optimization, the idea of functional grading, and the other one is about biodesign. We're doing a series of projects of biodesign, so we're working a lot with this idea, but we are still working a lot with other kinds of material systems and ideas of being able to functionally grade materials for very specific performances. And here I wanted to show it also because I know that you in Tongji are starting to, or are working with NIT, and I was very curious to that we could start sharing and finding ways of connecting our agendas. So this is Soirotia. Soirotia is a large-scale installation that we built for the ZKM Museum in Karlsruhe in Germany here in December. Yeah, so we just built it right now, and it's up for a few months more. It's very large scale. It's 19 meters tall. It can't remember how many square meters, hundreds of square meters of textile that we have knitted using our particular practice around knitted membranes. So it is a tension membrane that is set into tension through these active bent rods and compression sticks that are pre-tensioning the membrane across the framework. It builds on our work that we were building for the Biennale called Isoropia, therefore also the resonance in the name. But in Soyotia, we have been really trying to think about the grading systems, both structurally graded and materially graded knitting, grading systems, allowing us to work with a much finer understanding of how to produce the three-dimensionality and the material changes in the structure. As part of this, a large part of it has been really about developing or continuing to develop our interfaces between the design environment and the CNC knitting machine. So it's very much a project sited within the center of digital fabrication, allowing us to start thinking about, well, how can we, when we control the knitting machine, how can we be controlling material performance, and therefore material performance allowing us to control structural performance. Here in our project, we're working with these tension membranes. The membranes are pre-tensioned through a series of tension rods that pull out the material and allow us to understand the membrane as structural. We are grading it in two different ways, both materially and changing the yarns, but also structurally changing the actual knit structure along the way. We're using something called, we're using a jacquard stitch, and it's a double jacquard stitch. And then by intentionally allowing us to unravel the jacquard, we can in places extend the material up to 300%, allowing us to knit out of plane. So knitting machines are flatbed, or these are flatbed knitting machines, meaning that we're producing a flat material. But by this unraveling, we can make the material hyperbolic. We are also grading material color-wise, meaning that we are changing between different yarns. These different yarns allow us to control the color space of the installation as we move through from the sort of cool exterior to the warm other side of the structure. So here you can see some of the details of how we're moving across in the colors, but also in the dithering. And important for us is that these two gradations are not happening sort of as a simultaneous moment, but as two different gradings that are brought together through these dithering strategies that we have been developing. Soyotia is made out of 88 patches, so it's all mass customized. And when we are then controlling the knitting machine, we're automating the way that the programs are made. So this is important because if we want to really adapt knit into architecture, we need to be able to automate the fabrication files, because it's simply not possible to sit and hand program these extremely complicated knitting programs that we see in here. It's not possible to sit and do this by hand. It needs to find its own ways of going from design across analysis and to fabrication files. Yeah, so here you can see how it sort of ends in this very rich color space on one side, and on the front side it has this very large structure here. The second project I want to talk about comes from a larger framework of biodesign. So as part of the ERC project that Philip kindly mentioned, the Eco-Metabolistic architecture project, we are looking at three different perspectives into how we could produce with biomaterials from the harvested, the designed, and to the living. This is also a broader focus in CETA, in which we're working with mycelia and other kinds of bio composites, also 3D printing earth systems and growing fungi, also for living substrates, allowing us to think about materials as being fundamentally circular, not just circular in the sense of recycling, but also fundamentally circular because they are part of the global biomass that recycles through our steady state system at a couple of thousand years, if we believe Needham's core text on this. So that allows us to think about our materials as inherently temporal. They last just a few thousand years, and it binds this idea of circularity to the idea of a new architectural ideal, moving from the sort of classicist ideas of the temple built in stone as eternal, and moving into an idea of building materials as being something that is continuously produced, continuously constructed, continuously replaced as materials go through their own metabolisms and become. So when we start thinking about this, a living architecture, then we also start needing new kinds of representations that are able to work with this. In this project, we've been looking at biopolymers, predicting response. This is our pre-project to the ERC project, in which we've been looking at extruding biopolymers, which is a sort of, it's a xanthan gum-based recipe, which is using wood flour and paper flock as fillers and fiber reinforcement, allowing us to create a sort of extrudable slurry, a sort of wet slurry that can be extruded and then dried to create something which is somewhere between an MDF and a cardboard, but all made out of recyclable paper, and the binders are simply foodstuffs. So it's inherently very prone to decay. The idea of building with bio-based materials is of course not new. Already when we started working with fossil fuel equivalents prior to this and around the same time as we were building with this, the idea of biopolymers were also part. This is an experimental car built by Henry Ford, which is made out of soybean materials. And it is also connected to the great movement and interest that we have right now, where we start working with ideas of recipe sharing on the web or through fab labs, in which people are making their own recipes just as we have and refining them to the specific use cases that they're using in. So I know that Greg Lynn wrote this fantastic book called From Tectonics to Cooking Things in a Bag. It's a sort of second version of this now with a bio-based control. So in our project, we're working with cellulose flock, wood flour, glycerin, and xanthan gum, mixing it in a very, very straightforward way in a sort of bread mixer, and producing materials in which, when we are exchanging the materials, the composites we're putting in, we have tested with linen, with bark, different kinds of fibers, then we get different performances that are very easily testable and also very easily gradable, very easily to mix together. In our first experiment with this, we've been looking at how we can 3D extrude with a robot with these masses, and then create building scale elements, components, and bringing them together into a structural whole. Our first move in this project is actually to print at 90 degrees. It means that we print flat, the material is put together in this way, but then we turn the component and we build with it, so that we're using really the lamination between the beads. So every time the bead is moving, it needs to self-collate. This works very well with the xanthan gum binder. So we're using this inert or inherent strength in the material as the core constructive strength. When we are working with biopolymers, or these biopolymers, our choice here, they are highly state changing. This is because there's a lot of water in them. The water is important to make it extrudable. And when the water goes into it, then we get this quite large shape change that we need to correlate. What we can see is that we can print things, and we can also predict their change. We thought at first this would be quite non-linear. We thought geometry would impact on where things were drying more or less. We found that actually it is pretty linear, and we can quite easily with very straightforward statistical models, predict the shape change that is happening across the material. This has led to an emergent language in which we've been using the sort of print path to think about how things can be connected and reinvent joinery in this sort of squiggly line, or is a continuous print path that moves across the surface. It connects both in plan but also in section, allowing us to join elements together and to build up thicknesses of the wall components. This idea of material monitoring is really key to this theoretical framework. It is through the material monitoring that we can start talking about its temporality. In predicting response, and here now also in the ERC project, we've been working with different ways of monitoring the material systems as they change over time, tracking their geometrical shape change, as well as their sort of internal and external humidity rates, and understanding how that leads to material change. What we thought was that we would get a lot of variance in the way that things were contracting. What we learned was it was pretty linear. What we didn't know was that the very long drying rates of the material, as we scaled up into very large structural elements here, that they would simply rot. Mold would form on them if we didn't dry it fast enough, and therefore the drying conditions became very important for the project. As part of the project, we built these monitoring frameworks in which we can bring together different kinds of sense data, which is all time-stamped, which is then uploaded into online databases. Here it's Influx that we're using, by which we can characterize the material system in time under fabrication. And here you can see we're using LiDAR imaging, where we can see the material, the humidity, the temperature change, and therefore the humidity change over time, and we can track it in time and understand its drying rate. We can also see the impact on the geometry has on it. We can see that as things are, it's a bit slow this video, but we can see that as things are drying, then the place where we have better air access will dry faster, and places where we have lesser air access will dry slower. This allows us to be quite clear about how to dry the materials and also what the drying process produces of artifacts into the material, being able to statistically model the actual performance of the material in time. What we're doing right now is sort of multi-pronged. We're at one level looking at scaling up these systems. Here we're working with a large-scale copod printer. I think it has a print bed of, I think it's 5 by 5 meters. Our panels here are about 2 by 1 meter. So just trying to say, it's a bit dumb, no? It's just saying, well, we've started with printing something this size, then we start printing something this size. What happens when we start printing things that are that size? What the interesting part of these scaling up exercises really has is that the whole print technology changes, and so therefore also the behavior around nozzle shaping, adherence around how things are meeting each other across the beads, and also finally how we need to design the joinery within the single parts. You can see here the very large print head. So a second dimension in what we're looking at now is really trying to understand how we can change the binders in the material. And here we are changing from xanthan gum binder to animal glue binders, which are really interesting because they're more complex to print with. They need to be heated during their printing. As Philip will know everything from printing a lot of plastic. But at the same time, they are also interesting because they are thermoplastic, which means that we can heat them up again and we can reshape them. So we're very interested in this for printing things that maybe don't have this identity, but much more sort of thin and skin-like identities, and also how coating might allow us to think about these materials in the external environment. And finally, we are also excited by ideas of how to understand weathering, both as a sense of a sort of interactive relationship of hygroscopy, where the material is absorbing and externalizing humidity as part of being part of its environment, but also understanding weathering and therefore duration within the environment. We've done some initial tests, both on accelerated weathering machines, as well as just with external monitoring. And of course, if we put our sort of cardboardish like material into the world, it will fall apart. It happens very, very quickly. We have this very beautiful image here of 2 days after we had set our samples up. It rained very hard, and then everything fell down. That's not such a surprise. But of course, when we start entering ideas of coating, and especially biocoating, then we can start designing these performances quite specifically. We are there also interested in how these programs are part of more structural or more participatory, performative models of who builds, what does it mean to build, and when do we build, and who builds the building. So it challenges us. So if we're working in a bio-based material paradigm, then who is it that we are when we are inside of this building? Who is it that participates in this building practice? Is it built by experts and delivered to its user, or is the user part, or the inhabitant part of the continual construction that is biomaterials? And also by what technology is bio-based materials produced? If we are saying that we as inhabitants are part of these cycles of making, then how do we think about where the machine is? Are things prefabricated and brought and then assembled on site, very much like we do today? Or are machines part of that ecosystem that is the continual construction system? So is it part of your building to have its machinery, its facilitation of fabrication part of itself? And can we control that in a sort of Fab Lab-like manner, where we are participating in making our own buildings by emancipating the technological platform and placing it within the hands of its users? So I think these are nice and radical, while still recognizable ideas, but they are placed in a new orchestration. We know the Fab Lab idea, we know the co-design idea, but suddenly in this context, they take on new dimensions and new ways of thinking about participation and fabrication. And it inspires me to work towards a framework that can really start rethinking a modernist paradigm of us users of buildings as somehow passively accepting the building, and instead here becoming part of its making, which seems to me to be much more in resonance with the many other maker movement like identities that we see establishing in society. Thank you very much.
Great. It's a fantastic lecture from Mette. As usual, I think we can learn a lot from Mette. I think it's very Denmark style research. I think very focused, very elegant, and also have a ethical understanding of the future discipline. I think that's a great presentation today to us. We have a lot of questions. Firstly, I think the most impressive as a director of CETA, Mette, you actually play a very important leading roles over the 5 years. I think that's great. Very small team, but actually play a very important leadership around the world. I want to, is that possible for you to briefly introduce the framework of CETA and how you organize the program, especially the PhD program, and how you define different research teams? For example, you mentioned a lot of the 3D printing, testing workshops, and how you organize all these research in CETA. We want to know the details a little bit.
Yeah, thank you, Philip. Yes, I mean, I think that we sit in an academy. An academy is quite different from a big technical university. And rather than seeing it as somehow something that limits us, I think that our opportunity is to find the voice that an academy can afford. So what is it that we can do differently here that we could not do at a technical university? And I don't want to say that I don't want to compare it, but I think it's just important for us to think of it as a positive thing. And of course, I think the main thing about that is to, rather than trying to say, okay, now we've established these technologies, now let's use our next effort on trying to bring these into practice, so to create the technological transfer from research into industry. I think what we have been doing is to try to say, okay, well, we need to stay at the level of ground research. We need to stay at the speculative and ask questions that allow us to probe deeper into what are the next steps. And this has really allowed us to challenge the idea of what sustainability means in our field. I think obviously this is a global problem, but also I notice when I lecture that it's very different how much this is pushed as an agenda across different institutions. And it is true that from our perspective, from our worldview, there just simply is no architecture that is not sustainable. It's just over the time where you could sort of say, this is sustainable because everything is sustainable, everything needs to be sustainable, and we are part of a solution space that we need to take real responsibility for. So I think that has been some inspiring years for us to sort of kick back a bit and say, okay, how do we move this forward, and how do we get to think about how sustainability challenges us, not just as a sort of within a technological framework, but also within a sort of wider architectural framework of thinking society and the built environment together. So CETA is it's a small unit. We're about 20 to 25 people at the moment right now. It sort of varies day to day. So that's the research group, and then we have a master's group too. The research group counts everyone. No, it counts the professors, counts the PhD students and the research assistants who are working on the projects. So we work very much through a model of building research projects and getting funding for them. So it's very much through the councils that we're gaining funding. We also do quite a lot of intersectorial sort of consultancy where we're working with design practices, and we also have a series of industry PhDs. So for me, it's very important to think of research as having multiple perspectives. So to think of, well, there might be a cast-off right now. So I'm doing something that can be implemented tomorrow, but it also has a cast-off on the 5-year length, and maybe it has a cast-off on the 20-year length. And it needs, any project needs to be able to travel across those horizons, because otherwise it's simply development, or otherwise it's simply blue sky, and it doesn't really address the way we're thinking about, or it doesn't really, it doesn't really impact. So I think that's the main goal of what we're doing. And then CETA is highly collaborative. So we work with a lot of partners, both internationally, also interdisciplinary, also nationally, and also within CETA. So we work we're always changing partnership, which means that we work always together and we always transferring knowledge from project to project, which I think has been very, very helpful. Our PhD students are mainly embedded into the projects, which means we have very, very few standalone PhDs. And the more PhDs we have, the more helpful I think it is for everyone. It's helpful for the project, it's helpful for the PhD. It's very difficult as a PhD student to find the infrastructure of creating these demonstrators that we share with the rest of the field. This is our sort of base methodology of testing ideas, is through building full-scale demonstrators that are able to both sort of verify and validate the methodologies, but also propose things that are spatial and immediate. No, I can sense them with my body. I have a direct sensorial relationship to the proposition of difference that the technology and the conceptual thinking is making. So we embed the PhDs into the projects. This project here, which I've just been talking about, is to a high degree been made by Gabriella Rossi, who's our PhD on machine learning for fabrication. I think it's a picture of her. I just want to find her here. Sorry, a bit frivolous. There she is. So Gabriella has been with us for 2 years now and really been building up this system. And her thesis is not in biopolymers, or it's not in biomaterials, and it's not in 3D extrusion. It's in machine learning for fabrication. And what she's doing is trying to develop all these mechanisms of data harvesting, getting all the data in, and then being able to create the right algorithms and methods for actually trying to predict and understand the material deformation over time. So she's part of the project. She has an identified role within the project, but the project is also larger than her. And for us, this has been really helpful to develop these ways of sort of articulating the PhD, but also enabling her by being sort of a team around the production effort.
Great. It's great honor for me. You actually invite me to visit Copenhagen. I think it's 2019 or 2018.
Yeah, it's just before Corona, I think. Yeah.
Program. I think that's a great platform for the European PhD student. Actually, the students can exchange their ideas and also got some funding from this platform and make very deep research. So the most impressive and the strong impression to me is the interdiscipline and cross-discipline you mentioned, especially the material performance for the bio-based fabrication. The material is extremely important to understanding the new possibility. So I want to know how would you like to teach your student to find this special deep research into the materiality, especially in the 3D printing technology right now is the biopolymer have hundreds, thousands of options based on different materials. So how you engage into this process?
Yeah, so when we're teaching in master's level, we do a series. So we do every year, we have the fall semester, which is research driven, which means that the research project in the group, which is most most mature, or is at the right moment, or it's their turn, or we find a project. And 2 years ago, I think, no, this year and the last year, we've been working with biopolymers with the students, and we find that, and we then identify it as a specific question for the group, and we'll then run a series of workshop intensives that both have to the aim of skilling up generally the students. There are incoming students from all over the world. They might have different skill levels. They might have different, ideas of what steering is. They might also just simply need to learn very basic things. And then we use the workshops to actually start communicating, well, what is this fabrication method and how do you steer it? So what is a robot? How do you steer the robot? What is extrusion? What is a recipe? And then we bring to them quite curated questions. So we say we have quite preconceived idea of what a recipe can be, but then we allow for a lot of experimentation. So I've had wonderful students. We did a very fun project a couple of years ago where we were working with these bioluminescent bacteria and 3D printing with the bioluminescent bacteria, and where the students would go down to we are right by the harbor here, and they went down to the harbor and took water from the harbor and gave it to the bacteria, which is like, if you're a biologist, it's like the opposite. You want to keep things sterile. And the bacteria was super happy and glowed more than ever before. So it was very, so I think this sort of like wildness in the teaching situation can also create a lot of creativity, which is really helpful for us, fun for us to be part of, and to allow both the very curated but also the sort of inspired moment, the late night thinking, all of that, to bring that energy into our projects, and at the same time to communicate the methods and the sort of thinking of the projects to the students. And then, of course, we also teach the students their personal projects in which they are developing their own practice, and that is situated within a sort of more theoretical and also ethical framing device, in which we are presenting them with different lectures which are allowing them to really reconsider what is the role of architecture, where is the field going, what will a building be in a sort of post-carbon society, and ask the very, very large questions. I think that is really helpful. At a PhD level, it's more integrated. No, I think they are more sort of integrated into the actual practice of the studio, and they are co-producing with us. We are working together to develop these solutions, and they have a lot of say. We all go to our project meetings and we're developing the project, and so therefore it's a team effort, and everyone in the team has a particular voice that can solve questions and also define questions, which is equally.
Yeah, I think the most impressive, this morning we have the lecture from Daniel, who is from the States, actually working in Imabro, is quite immaterial, I think, intelligence, which is very abstract based on the algorithm and artificial intelligence. But the theta, I think, give us another, I think it's like the other side of the coin. It's material intelligence, I think, which based on the new materiality actually respond to the post-carbon, post-humanism. I think that's extremely important topic around the world. And here in China, also the low carbon strategy or policy put on the table. We should address our discipline future based on the post-carbon issue. And this is why we invite you, because the Digital Futures topic is one planet. I think you're also make an introduction on the terraforming the new planet. I think we should be thinking on the ecological and sustainable features or aspects of the planet. And maybe your research and CETA style is quite based on the material intelligence and the material process, actually, which is extremely, like you mentioned, the smarter with less. I think that's like a manifesto to become more smarter and saving and producing new efficiency of the fabrication process. That's a sustainable future for extremely for the discipline to the architects. Another question, I think Copenhagen is a very charming and dreaming city in the world. I also curious, I think you have a lot of very good designers and education schools in your country, although the city is not a big city, but very good design, architecture design companies, which leading the fashion, leading the concept in the world. So could you make a brief introduction? How do you address CETA in such a context with the city, growing of a city, and with a culture of creating creativity in Copenhagen.
Sorry, can you just repeat the last, if I could make an introduction?
Yeah, I think, yes, I think Copenhagen have a very strong creativity culture in the world. A lot of design firms play the leading role. And we know a lot of new names, and also the projects and the city are growing with the designers, with architects. So I want to know your research, Sita. How would you like to, or how did you participate or engage in the city culture?
Yeah. It's a good question. I mean, we participate in the way that we do a lot of industrial PhDs with different companies. And then we also have this consultancy role. We have worked a lot with different companies where we have advised them on different material systems, not only in Denmark, but also in Germany, and sort of where we have our right connections. But I would like to have a stronger role. I think it could be great if the voice that we had could have a sort of more direct relationship to what practice is undergoing. And here I think the UIA project is really helping us towards having a more direct interfacing with the companies. Right now it's sort of very one by one. I think it's very positive because we work, the industrial PhD is 3 years, and it allows for real dialogue to form and for real interaction to happen. But we also know that the life in the offices is much quicker. So InnoChain was a great tool for this, because in InnoChain we had 15 PhDs across Europe, but we also had, I think it was 18 industrial partners from all over Europe participating. And it allowed us to have, again, this very long conversation with them, over many years, in which we could start teasing out what are not just the sort of, I want to build this building in steel, what is the best structural analysis I can do, or can I optimize, whatever. But also sort of what are the methodological bottlenecks that our practice is up against. And I think was really the key contribution of InnoChain, was to allow us a better, stronger insight into how to understand practice as a whole, future practice as a whole. So I think the driver right now is to get a stronger relationship to the offices through the image of sustainability. And here in Denmark right now, there's a huge effort into looking at bio-based materials. So this has sort of emerged in a way after us, but not really because of us. I think it just somehow emerged at the same time, and has been driven by this carbon counting that the UN sort of puts on all societies. And it's very good to be carbon counting if you're a big country like France or the UK or US, maybe China also, no? Then you have these very, very large countries, and it makes sense to count carbon. But in Denmark, for instance, of course, one of the most low-hanging fruits is to transition into timber construction, which is what we see everywhere, no? But as it's done by nation, and as we are a very, very small country, we don't have forest. We are a very good agricultural country. To grow forest on our fat land would be meaningless. So we don't have a lot of forest, and we buy the forest or timber from Sweden, which has, Sweden is an enormous country. And this means that when we use timber, it doesn't go into our calculation of CO2, it goes into Sweden's consideration. And this has led, it's a really weird paradox, but it has led to a very strong innovation, because suddenly people are saying, well, what are the biomaterials we can make here? And Denmark is like Greece. We are made out of 500 islands. We have a lot of sea. So maybe there can be marine-based biomaterials like built on seaweed and so on, which is very innovative, no? But it comes from this sort of strangely bureaucratic notion from the UN, which doesn't take into account that countries have different size, but it brings with it a very innovative challenge to our context. So I haven't seen any of these bio-based marine-based materials except for these algae polymers, but I'm very curious what this can lead to.
Great.
Yeah.
Yeah. Thank you. We have a lot of PhD students here. And do you have any question? Probably because you mentioned one project about the knitting membrane. We have a PhD student here, Virginia, who is also working right now as a researcher in University of Michigan. Would you like to put forward some question, Virginia?
Yeah, I don't really have like a specific question about that project because I've seen it presented before, but I think it's really interesting when you're looking at knitting because it can be so complicated to make sure that all the stitches are taken care of and that certain stitches don't get dropped, or making sure all of the transfers are secure. And I guess some of my question is, in the process, how do you relate back and forth between the kind of very small detail level of individual stitches and the larger scale kind of whole geometry of the thing? Because I think it's one of those materials that really has to work at both levels.
Yeah, I think it's such a good question, because when you have your nose all the way down in it, then you're thinking about these things. And when you look at it from outside, I'm sure you don't really, it's not the first question you will ask. But I think in Zoerotia, this is really the center of the project, has been to be able to create very global grading strategies that were then able to be translated into the single unit and then on into the actual knitting code, as you can see here now. So what we were doing here was it's as I was saying, it's graded with two different grading strategies that are not just sort of the same, but they're different. And one grades the structural knits, allows us to extend the noses, which is what we see here now, that we get this unraveling of the yarn, which allows it to become much larger in these noses. And then the other one is that we're grading the color, so we're changing the yarns incrementally across the structure. And here we created a series of sort of diagrammatic tools that were able to allow us to sort of control. Here we're controlling the yarn color now, so we're controlling it across the whole membrane, the whole structure, and then translating it into, because when we're knitting, it's a jacquard, so there's only two, or in our jacquard, there's only two yarns. So it sort of translates into something that is inherently, in reality, it's binary, no? So it's 2 times binary on top of each other. One level binary on structure, whether it's unraveled or not, and one level binary in color, which are the 2 yarns that we're knitting together, and which is at the front of the fabric. So in that strategy, we created these different methods. I was just looking if we have no, I don't have the diagram with me, but we created these strategies for then picking colors across this diagram, like a height map, and then being able to control sort of the global gradation at local level, and understand how the local level, what were the parameters of that could inform at global level. I don't know if I'm answering you super precisely, but I think it is really at the core of the project to be concerned with these things. And then, of course, the other thing that I think, Virginia, you will also have under your skin now is this idea of getting from the sort of knit instruct, or the knit diagram, to the thing that can actually instruct. And here we create these interfaces that are generated in Grasshopper, where we are generating these pixel files. And then as we create them, then they are then imported into a sort of automated color coder in the CNC knitting software that then generates this code. But that translation in which we're taking not only the sort of color information, but also the machine information into account, I think is really important. So how to, or it's a conceptual step, I want to say, because of course, when you're knitting, and it's like 3D printing, that the nozzle or the yarn carrier, in our case, it is a physical thing that is somewhere, and it can't just appear. You need to drive it out to the side, and this creates a sort of correlation between the code that you're creating that is actually controlling the stitching or the knitting, and then the code that you're creating, which is actually just steering the machine, which is things that we also know from other robotic processes. So I hope I answer your question.
Yes, thank you.
Thank you. And also remind, we actually have another pavilion in Venice Benetti, 2018. There's also a beautiful pavilion. I still remember that. That's great. And last but not least, I think we have a lot of opportunity right now in the future to set up some new collaboration, potential international collaboration partners. For example, the low carbon strategy and standards, and also the manifesto. Is that any possibility to have further collaboration with you to applying for certain grant or funding around the world? Maybe in China, we have some international collaboration funding to especially focus on the low carbon research topics, and could be also based on some PhD exchange program. We can send in some PhD students, candidates from Tongji and sponsored by NSFC from China to exchange 1 year to come and to go to CETA to make some certain topic research with you. I think we have a lot of potential possibility based on our long-term collaboration and friendship. And also we are looking forward to see what's happened for the UIA Copenhagen 2023. You and both you and Carretti actually play the leading roles in the sustainability topic. And we're looking forward also to see some achievements or some special events based on this topic research. So thanks a lot for your organization, and thanks a lot for your contribution to Digital Futures. So thanks a lot for this lecture.
Thank you very much for inviting me, and thank you very much for today. Yes. Great.
Thank you. Thank you so much. I think it's already 1 hour and a half. So thank you so much. We want to end here. See you soon. Let's keep in touch.
Speak to you soon. Great. Thank you. Bye bye.